Get a Job in Tech, episode 288. Java technical interview questions. Data structures and algorithms. Question 1. What is the difference between an array and a linked list? In general, arrays are a good choice for data structures where the data is accessed frequently and the order of the data is important. Linked lists are a good choice for data structures where the data is inserted or deleted frequently, and the order of the data is not important. For example, you have a feature, which is data storage. The array would be contiguous memory. A linked list would be non-contiguous memory. Feature would be access efficiency. Array, high. Linked list, low. Feature, insert deletion efficiently. Array would be low. Linked list, high. Feature, order of data. Array, important. Linked list, non-important. Question 2. Explain the concept of a hash table. A hash table is a data structure that maps keys to values. It is a very efficient data structure for storing and retrieving data, as it can access data in constant time. Put, which is a key value, this method stores put key / or comma value. This method stores the key value pair in the hash table. Get, in quotation, key. This method returns the value associated with the key. Remove, quotations, key. This method removes the key value pair from the hash table. Question 3. What is the time complexity of various operations in a binary search tree, BST? The time complexity of various operations in a binary search tree depends on the height of the tree. The height of the binary search tree is the number of nodes on the longest path from the root node to a leaf node. A table, for example, if you have a table, left-hand side you have operations, right-hand side you have time complexity. So under operation, you'll have search, and then the time complexity would be O parentheses log space N. Operation insert, time complexity, O or 0, quotations log space N. Operation delete, time complexity, 0, quotations log space N. Operation in order traversal, time complexity, O or 0, parentheses N. Operation pre-order traversal, time complexity, 0, quotations in. Operation post-order traversal, time complexity, 0, quotations in. Question 4. Describe the difference between breadth first search and depth first search algorithms, or DFS. So you have BFS, breadth first search, and depth first search, DFS algorithms. Here is a list of tables that summarizes the difference between the BFS and DFS. So you have the feature, under feature, explores. Next to that, BFS, breadth first search. You're basically getting the difference between the two. So you have under feature, explorers. They're BFS, all nodes at the current level before moving on to the next level. Under DFS, as far as possible down one path before backtracking. Under the feature time and complexity. For BFS, you have 0, quotations V plus E. Under DFS, you have just V. Feature, space complexity. BFS, you have 0, quotations V. DFS, just V. Feature, use cases. BFS, Finding the shortest path, finding all of the nodes in a graph that are reachable from a given node. For DFS, finding all of the nodes in a graph, finding all of the paths between two nodes. Question 5. Explain the concept of a priority queue and provide an example of its application. A priority queue is a data structure that stores elements along with their associated priorities. It allows efficient retrieval of the element with the highest or lowest priority. The priority determines the order in which elements are processed or accessed. For example, a priority queue can be used to schedule tasks in a time-critical application. Each task is assigned a priority, and the tasks are scheduled in order of decreasing priority. This ensures that the most important tasks are always scheduled first. Question 6. Explain the concept of dynamic programming and provide an example problem where it can be applied. Answer. Dynamic programming is a problem-solving technique that involves breaking down complex problems into smaller overlapping subproblems and solving them in a bottom-up manner. For example, knapsack problem. In a knapsack problem, you are given a set of items, each with a weight and a value, and a knapsack with a limited capacity. The goal is to find the subset of items that has the maximum value and that fits in the knapsack. Question 7. What does a hash set work? How does a hash set work internally in Java? Answer. A hash set internally uses a hash map to store its elements. When you add an element to a hash set, it is first hashed using the hash code method. The hash code is then used to find the corresponding bucket in the hash map. If the bucket is empty, the element is added to the bucket. If the bucket is not empty, the element is compared to the other elements in the bucket using the equals method. If the element is equal to any of the other elements in the bucket, it is not added to the hash set. Question 8. What is the time complexity of various operations in a hash table? Answer. The time complexity of various operations in a hash table depends on the hash function used and the number of elements in a hash table. In general, the time complexity of the following operations is insertion, 0, parentheses 1 on average, 0, parentheses in a worst case. Search, 0, parentheses 1 on average, 0, parentheses in a worst case. Deletion, 0, parentheses 1 on average, 0 in worst case. So these are some of the questions that you may be asked for your technical interview on Java. Thanks a lot. We'll see you in the next one.